All right. So hi, everyone. I'm Ali, and I'm going to talk about direct alignment with heterogeneous preferences. I realize that machine learning community has invented a lot of new terminology in the past few years. So I'm going to spend half of my talk explaining what do I mean by heterogeneous preferences, what is alignment, what is direct alignment. And in the second half, I will fast track through the results, okay? So what is heterogeneous preferences? Specifically, I'm thinking about a policy which outputs some response, like a chatbot. You can call that Y. And then I can think about the notion of reward over that space of responses. And when I say, heterogeneous responses, I mean that there are different peoples with different notions of rewards. For the sake of this talk, I'm going to use a very simple example. Suppose that you want to create a coffee machine. And maybe there are, the parameter of control, the output is basically the temperature of the coffee. And I'm going to say there are three people in the world, three types of people in the world. Some people like iced coffee, some people like hot coffee, and there are some people who, like lukewarm coffee, maybe. So that's what I call heterogeneous preferences. And right, now we have a notion of preference or reward. We want to come up with a policy that actually gives us a coffee machine. If we actually know these reward functions, and we also know which type of user is interacting with our coffee machine, then the optimal policy is kind of simple. So I'm going to serve this temperature of iced coffee, hot coffee to these people, and I'm going to serve mediocre or lukewarm coffee to these people. In practice, it's a little more difficult. We are often exploring a huge space of language, maybe, and for practical reasons or other interpretations of the reward, we often start from a reference policy. So the optimal policy is not exactly like that. It's not exactly deterministic. It's going to look like this. And we often do reinforcement learning when we have the rewards, okay? So that's what I call personalized policy learning. And now I can discuss what do I mean by alignment. Imagine a setting where I know that what are the user types, but I don't know the reward function per user type. What can I do? I can probably collect a preference data set like this. I see, a user of type A has preferred 40 degree to 100 degrees, something like that. And then I can maybe learn the reward functions from this data set and do Ariel, which is often called reinforcement learning from human feedback, RLHF. Or sometimes I can directly go from the preference data to the policy space. It's what we call direct alignment. And the most famous method here is DPO. So this is what I call personalized alignment. For the rest of talk, I'm going to be focused actually on direct alignment, which is going from the preference data set to the policy space directly. So what's the challenge here? I'm assuming that I have a data set with all the user types, and I also know which type of user I'm interacting with at the inference time. This might not be the case. This is what I call direct alignment with heterogeneous preferences. So I still know that I have different types of users, but I actually don't know who I'm serving. And I also don't know who has labeled my data. So I know nothing in training and in inference. And this is what I call direct alignment with heterogeneous preferences. What's the task here? Still, we want to come up with a policy that serves everyone. And if we want to define or design a policy, we need an objective, which means that we sort of have to decide how we would like to aggregate different notions of rewards. Okay, I can't see the rewards and I can't see the user types, but I need to sort some sort of aggregation to define my objective. All right, so it turns out there are not many options. If I'm going to define an aggregated notion of reward as my objective to maximize that for my policy, I can only use affine combinations of them. That's a limitation of the pairwise preferences that I have. I'm not going to get into that. But let's say we choose something really reasonable, like the user-weighted average reward, like this black line here. Let's say for the rest of this talk, our task is to maximize the average reward. And if we decide to do that, then the policy will look like this, which I think makes sense. If you go to that coffee machine, there's a 50% chance that you get an iced coffee, and there's a 50% chance that you're going to get a hot coffee. That's okay. You might ask, okay, if that's the task, maybe I can just apply DPO out of the box. And I'm going to tell you, this is going to be the output. Most of the time, you're going to get a lukewarm coffee, which is not desired for the majority of the people. So what's the issue? The issue is that DPO is not maximizing the expected reward, is doing something else, is actually consistent with word account, the notion of voting. And we don't like word accounts. That's one reason. There are also other reasons which I'm going to mention. So the rest of my talk is going to be, actually, I forgot to mention that this issue is not actually about DPO. It's actually more broad and also observed in some other studies. Okay, for the rest of my talk, I'm going to answer this question, can we do better? Hopefully, we can always do better. The answer is going to be yes and no, and I'm going to get into that. But before that, I just want to briefly mention why we don't like bird account. There was one reason which you just saw, because we don't like lukewarm coffee. There are also other reasons. If you're familiar with social truth theory, bird account is going to violate independence of irrelevant alternatives. Bird account is going to suppress minority in some sense. And bird account is going to be sensitive to how you have collected your data set. You don't need to read the math. I'm not going to discuss that, but just wanted to mention that we don't like bird account. These are all theory. Is this even like a real issue? Do we actually see that the bird account is actually different from maximizing the average reward? And the answer is yes. We try to look at some surveys from Pew surveys. Those are about social and political issues. And as you can guess, these issues are very polarized in the States. So we look at those things. And for example, this is an example when people were asked, are they going to buy an EV or not? And we often see that if you maximize the average reward, that's going to be very different from calculating the bird account. And it's actually not only this example, it's quite often in 10% of this social political questions, we're going to see a discrepancy between what bird account is going to give you and what maximizing the average reward is going to give you. Okay, all of these are the side. I just wanted to mention that why making the homogeneity assumption is consequential. And then now I'm going to get back to this question that can we do better than DPO? So let's say that I have this data set which I had before. It's kind of anonymized. I don't know who has labeled this data set. Can I do better than what DPO was already doing? The answer is no. I cannot actually learn the optimal policy that maximizes the user-weighted average reward without any information during training. So that's sad, but that also means that we should do something maybe. What are the solutions to get around this? One way is to collect some information from annotators during training, maybe like their demographics, for example, so we know who has labeled this data. And the other one might be to kind of relax the objective that we have, because we're trying to consistently learn the optimal policy. And what does that mean? That means that if you give me infinite data and perfect optimizer, I would like to recover the optimal policy in that limit. That's a very minimal thing to ask, but it turns out that this is too much actually to ask, this sort of consistent learning. So can we do just one of them and not the other one? It turns out no. If you just try to relax the requirement of doing a consistent learning, still you can do nothing without having any information about your annotators. You need to know who has annotated this data. So that's gonna be, the final solution should look like this. We need to collect some information from annotators during training, and we might need to relax our objective of consistent learning. I'm gonna briefly discuss this too. So let's try to collect a little bit more information. So instead of like asking one question from annotators, let's ask them two questions. And it might be a little puzzling that why is it useful? And if I want to answer that, I need to get into like why DPO is actually not doing well, but I'm not going to do that. I'm just going to tell you that if you collect data like this, which is not too much to ask actually, it's just matching two different responses of users, we can actually improve DPO to the first order. So we can do significantly better. So that's interesting. Just minimal change in the data collection, it means that we can do significantly better than the standard DPO. The next question is, can we completely solve this problem? Because maybe first order correction is just not enough. And to answer that, let's say that we have a really, really rich data set. For every question, we have asked a representative of a user type to tell us whether they like that or not, and what's their preference. So if we have such a rich data set, which is too much to ask, then yes, we can consistently learn the optimal policy when the preferences are Bradley-Terry. It's just a common assumption there. That's a good news. If you don't have like many user types, maybe if you only have like, I don't know, left or right or something, some political parties, that's fine. And we actually show on some helpfulness, harmlessness data set that using our new objective here is going to be very helpful when we use that on llama. But it also comes with a problem if it's going to be very sample inefficient if you have many user types. And that's not an issue with our method. That's a fundamental issue with direct alignment, which is maybe the most important result of this paper, that there exists no sample efficient estimator of the optimal policy if you want to do direct alignment. With that, I would like to conclude. I hope that I have convinced you that the preference homogeneity assumption is consequential. You don't want to have a lukewarm coffee, maybe. Also, I would like to emphasize that we need to collect some annotator information if we want to make progress on this problem. And minimal information is just enough, something like paired preferences as I showed you. We can completely solve this problem if we had a very rich data set of annotators, but that turns out to be computationally hard, also sample inefficient, which means that if we want to remain sample efficient and completely solve this problem, that's kind of impossible. So maybe we need to give up consistency and try to do approximate alignment, or maybe just don't do direct alignment, do RLHF. So that's it. I just want to emphasize that everything I told you is about this notion of user weighted average reward as the objective. And I even didn't discuss that is it actually right that we can assume a notion of reward per users or not? So these are sort of assumptions that I had. And I would like to say that I do not recommend, even if you're doing consistent direct alignment, I don't think we should use language models to represent humans or simulate them. That's a different thing I wanted to mention. Thank you. So fast.
Hi. Yeah, thank you. Very interesting talk. I was wondering if you'd considered like doing some sort of soft labeling, like via clustering, because so you said like obviously with more labeled data that would be an advantageous approach, but like could you do something clever and unsupervised to say, okay, well these two types of rankings are similar, maybe it's the same person who wrote them, and could you get any performance benefits that way?
Excellent question. So we started from this constraint that we want to do like one optimization, which is, I want to do one optimization, one direct alignment on my whole data set without identifying user types, because I might have like, tens of, or I don't know, hundreds of user types, which I might not even be aware of. But that's a very good question. I think actually a real practical solution might be to do something unsupervised and then try to align to them like, individually and finally aggregate those results. So that's a very plausible solution if you don't want to do direct alignment. But all of these negative results that we see here are about like doing one optimization. And, I want to go directly from my preference data to the policy without doing any intermediary step. Yeah.
Yeah, I want to thank you for your talk. I'm wondering if you could clarify your derivation of the placket-loose model. I know that Kemeny would be the placket-loose model that you were fitting. I think it was like on the third slide or something when you were just.
Yeah, I don't.
So Borda is a maximum likelihood estimate
Yeah,
under
yeah,
certain
yeah.
conditions. So I'm wondering why it wouldn't hold for this case.
Yeah, that's a good point. I don't have them on the slides, but we use that model when we are working with the survey data, and their options are kind of limited. because they're like, multiple choice questions, and we could actually, manually estimate the reward functions in the Placket loose model. So that's sort of thing we did. That was kind of like manual because it was not about the language. It was just like 4 options, and it was kind of easy to estimate human rewards. That's why we chose survey data to simulate that. But yeah, I don't have that on this slide. I can follow up with you offline. Yeah. I want to add, okay, yeah, I wanted to add one more note. Yeah. Oh, I don't need to reweight examples. Yeah, I mean, any objective which I'm using has like equal weight for all examples. I don't need to reweight them because these examples are basically, I'm assuming that they're coming from a representative population. So means like maybe it's very small, like some different references. Oh yeah, yeah. That example, yeah. Right. Something like that. Other ways like waiting on some. Sure. Yeah, no, yeah, that makes sense. I think that example that I showed you, that coffee machine, I was assuming that different users have similar weights, so different user types are kind of equally weighted. But we could avoid that problem if the lukewarm coffee likers were minority. So okay. Okay, yeah, and I wanted to say one last note, which is that this project this is for my fellow PhD students or friends. This project came out of a student-run reading group without advisors. Then we found advisors to publish this. So never underestimate what you can do with your friends. So without advisors. So yeah, I just want to mention that.
Thank you again.